All right, guys, I'm going to go ahead and go over some examples from yesterday's homework on 9-4 to clear up any issues you guys might have had. Remember, that was rationalizing the denominator, where we can't have a radical in the denominator. We have to get rid of that. So for this first example, I need to multiply the top and I need to multiply the bottom by the square root of 3 over 3. Think about it. The square root of 3 over 3 is 1. So I'm multiplying this fraction by 1. That doesn't change the value. But what it does do is it allows me to get rid of that radical in the denominator. So watch this. The square root of 3 times the square root of 3 is 3. And the square root of 2 times the square root of 3 is the square root of 6. Now, obviously, this 6 and 3 can't be reduced because that 6 is under the radical, okay? Let's look at this second one. We can use our quotient rule here to make this the square root of 5 divided by the square root of x. And now we're going to multiply the denominator by the square root of x, and we're going to multiply the numerator by the square root of x, okay? The square root of x times the square root of x is just x. And the square root of 5 times the square root of x is the square root of 5x. So that's just a couple simple examples to get us started. Multiplying by whatever your denominator is, what's underneath the radical. All right, let's step it up a notch and do a couple that are a little bit more difficult. Hopefully these examples that I'm going over now will clear up any issues you guys may have had with your homework. And let's do, okay, here's two more examples. This first one, we have a fraction underneath the radical again. So let's use our quotient rule and make it the square root of 1 over the square root of 27. Let's not multiply each by the square root of 27 because the square root of 27 can be simplified. Remember, I can break this down into 9 times 3. Okay, so I have the square root of 1 over the square root of 9 times 3. 9 is a perfect square, so we take the square root of 9, which is 3. We bring it out front. So now I'm here. And now we need to multiply by this square root of 3 to the denominator and the numerator. Times the square root of 3. Times the square root of 3. The square root of 3 times the square root of 3 is 3. 3 times this 3 is 9. And the square root of 1 times the square root of 3 is the square root of 3. Final answer, square root of 3 over 9. This example here, the 2 can't be broken down, so we're going to multiply both the numerator and the denominator by the square root of 2. The square root of 2 times the square root of 2 is 2. 7x times the square root of 2 is 7x times the square root of 2. Notice this 7x wasn't underneath the radical, so I don't multiply the 2 times the 7x. That 7x stays out front. So that's your final answer. Now, let's try a couple when we have 2 terms. All right, so check this out. We do have a radical in the denominator, but we have 2 terms in the denominator. Remember, when we have 2 terms and one of them's a radical, for us to rationalize the denominator, we have to multiply by its conjugate. Okay, so it's two terms. The conjugate of the square root of 5 plus 2 is the square root of 5 minus 2. So I'm going to multiply the top and bottom both by that conjugate, the square root of 5 minus 2. Now keep in mind, this is a binomial times a binomial. These are conjugates. When they're conjugates, I just have to do the first times the first, the last times the last. Square root of 5 times the square root of 5 is 5. 2 times negative 2, negative 4. 6 times the square root of 5 is 6 square roots of 5. Minus 6 times 2 is 12. We can simplify the denominator. 6 times the square root of 5 minus 12 over 1. Okay? Let's try one more with the conjugate. Let's go square root of 3 plus 1. Or let's do, let's try this one. Let's go 4 over the square root of x minus 1. All right. Again, we have another example where we have two terms in the denominator. So I have to multiply by its conjugate. So I'm going to go times square root of x plus 1 times square root of x plus 1. These are conjugates, so when I multiply them, do first times first, last times last. Square root of x times the square root of x is x. Negative 1 times 1 is negative 1. On the top here, 4 times the square root of x is 4 square root of x. 4 times 1 is 4. Okay? We can factor out a 4 here. But there's no canceling I can do, so I will accept either answer. Okay? And I want to do one where we do have to simplify. Where there is a GCF we have to take out like that one, where we can cancel. We had a couple last night for homework that were like this. Okay. And if you look at this example, I don't have a radical in the denominator. I'm not rationalizing the denominator. I'm just seeing if it's fully simplified. I have two terms on the top, 9 and 6 square root of 2. So look at these two terms. Is there a GCF, a greatest common factor, that I can take out of both of those terms? Yes, there is. I can take a 3 out. So I factor a 3 out of the top. And when I do, I'm left with 3 plus 2 times the square root of 2 all over the denominator of 3. And now the 3's can cancel. That's my final answer. Okay, one last one, and then I'll call it quits for the day. Final example. 8 minus 20 times the square root of 3 all over 4. Okay? All right, I'll tell you what, let's change it up a little bit. Let's make it over 2. Let's check it out. There is no radical in the denominator, so I don't need to rationalize it. So I look up top, it's two terms. Is there a GCF I can take out? Is there a number that goes into both 8 and 20? Yeah, 4. So we take a 4 out, which would leave me with 2 minus 5 times the square root of 3, all over 2. I can now reduce the 4 and the 2. That becomes a 1. That becomes a 2. My final answer, 2 times 2 minus 5 square root of 3. Okay? Guys, we're going to have a quiz next week. It'll be over 2 days, and it'll be on 9.3 and 9.4. And I'll have a little assignment that we're going to do today that will kind of tie those two sections in and kind of be a study guide for the quiz. I know we're off of school on Friday, so we won't have any homework over the weekend. We will have an assignment that's due tomorrow morning, Friday at 8 a.m. will be that little study guide, and we'll have a quiz next week when we return. Thanks, guys.